Well, hi everybody, and welcome to my shop again. And here it is, 2014. I think it's January 3rd or 4th. My watch cannot be trusted. It's January 3rd, and it is very cold here. It's minus 25 outside, and that's really cold for around here. Minus 15 is typically very cold. Minus 25 is really, really cold for this part of the world. And cold enough that people were hearing frost quakes this morning. A frost quake. Now, I don't know if I've ever heard one. I frankly never even heard of it until this morning. But when you get a very significant cold snap and it causes the ground to freeze deeper and deeper, the freezing, of course, water expands, builds pressure in the ground, and the ground will heave and make a quaking sound. So that's how cold it is here today. Now, it's not so cold in my shop. The furnace is running right behind me here. I can feel the heat from it. So I'm fairly warm down here. And today what we're going to try to do, I got the old Heathkit out again. This is the one where I tried to make the radio work and really got nowhere with it. And now I'm very suspicious because the other kit that I did make the radio with, it turns out it has a defective component right in the kit parts. I'm wondering maybe the same thing has happened here. Of course, I'm suspicious about the transistors. These are relatively delicate and can be damaged by rough handling, bad circuits and stuff like that. The rest of it, well, there's really not much else here to break down. I wouldn't even expect the capacitors to be weak or poor. And this coil here has this burn mark on it, which you can see in the camera right now. So the other problem with this, which is what I checked out yesterday off camera, is this whole thing is built as a kit. So all this wiring has been done by somebody, maybe even a 10-year-old kid for all I know. And I checked through it all very carefully yesterday. There was one wire which really wasn't making contact properly. One wire over here, which happens to be part of the circuit. So maybe that was the whole problem. But anyway, they're all connected. At least they're all pressed under their screws now properly, all the wires. So I don't think there's a problem under here. And let's just check the potentiometer in this kit, since the potentiometer in the other kit turned out to be a dud. Really would be surprised. Pop these wires off because we're going to strip all the wires out of here in a moment anyway. Okay, I'm getting 80K. Come on. Tell me this one's also not working. There it goes. Very, very, very poor contacts here. And maybe that's the whole problem with this kit is, let's experiment a little bit. I'm just going to check the check the contact quality here. You're touching the same spring contact in two places. Oh no. Yeah, that's... My understanding is copper oxide is actually conductive. So you don't have to worry too much about oxidated copper. And nearly all the copper we look at every day is oxidated. It's not bright and shiny, it's slightly dull. Yeah, you know what, there's no problem making contact with these. So, I'm going to pull away all the wires here. That's one of the cool things about these kits is, man, it's easy to remove the wires. Destruction easy. And what we're going to try to make here is a wireless microphone, basically. There we are. Stripped away. The wireless microphone. Where'd it go? Voice transmitter. There it is. It's got the connecting chart. And it uses 2 transistors. See them right there. There's the connecting chart. Tells you from pin 1 or connecting point 1 to 11, so on all the way down. And there's a diagram of what it should look like when you're done. And there's a little guy there. Apparently he's about to eat the headphone, the earphone. Yeah. I love those goofy little guys they put in here. These guys are my favorite here. Yeah. Okay. So let's hook this up and see if we have luck with it. From 1 to 11. From 11 to 21. 11 to 21. I was thinking some more about these things for not just children, but for older people who maybe people like me, maybe people like you when you get older. Maybe you are older, I don't really know who you are who are watching this right now, but you know, these things could be fun. And I wouldn't say go out and get an old one like this. I'd go buy a new one. And of course the newer ones have a lot of computer type circuitry in them. 11 to 14. Okay, 11 to 14. 14 is down here. You know, whatever it is you're interested in, you can probably get a kit that kind of focuses on it. And I suppose with a little bit of creativity, you can kind of generate your own circuits with these things. It probably for an older person, that would really raise the challenge. Tremendously. You'd kind of think too, the guys who designed this, they pretty much thought of everything they could, because if they can think of 10 more, can't get this. Shouldn't use stranded wire on these things. It's not the best. There we go. I've even thought about the practicality of using these things in a shop like mine because it has an array of parts laid out, all labeled. So if I need to quickly try, well, what would happen if a 68K resistor, I don't have to go digging for one, it's right here, it's all laid out. Thought about it, haven't decided if I'm going to do that at all. Next one, 2 to 8. 2 to 8. I suppose it'd be helpful if I laid all these wires out by length. before starting also. And I was thinking a little more about the extraneous equipment you might need to really improve this, and a multimeter would be a really smart addition. Yeah, I'm thinking about a kid. If a kid were doing this, okay, 8 to 12. I think a multimeter would be a really excellent addition. Oops. Because I think all of us who do this kind of stuff with electronics, we know we can't get anywhere without a multimeter at a minimum. So that was 8 to 12. The next one is 12 to 15. 12 to 15. And you know, these things, I think they eventually led to this kind of thing. Right, this is my breadboard from college. I went to college in the 70s. And that's like a different version of this, if you like. Well, not much to it, is there? No, you gotta put some parts on it. But I'm losing track. Stay focused. 12 to 15. 7 to 19. 7 to 19. Yeah, staying focused. Not one of my strong points. To 19. There we go. 7 to 19. 19 to 45. 19 to 45. That's here. And here, I think here's the other extreme. This is a single conductor wire, but it's pretty stiff. And if you move the wire, it tugs on the connections. So you want the flexibility of a stranded wire, but you don't want the strands at the connection point. So maybe it's a stranded wire with soldered ends would be the best move on this. That's probably what the kits come with in the first place. So we did the 44 to 13, so 44 to 13. $44 to 13 and away. 44 to 13. 44 to 13, 13 to 36, so 13 to 36. Now, come to think of it, when I was young, one of the first things I got my hands on was a multimeter. It was this terribly cheap little, battery testing multimeter. But man, did I ever explore the world with that thing. 13, 36 to 57. 36 to 57. Hey, 57. We're way over here now. 57. Well, that's a battery connection. So we won't make that. We'll just say that's one of the battery connecting points. That would be the negative side. So that was up to 57. Now 59 to 64. So 59 to 64 is a switch. 65 is the other side of the switch to 60. Where is number 60? 60 is here. So 60 comes down. 65, 64, back to 59. Okay, so they're just interrupting the battery supply in the middle here. 58. 58 is the other, is the positive side. 58 goes to 29. So 29 becomes the positive terminal. There's 29. And there's no power on right now. 29. Now 29 goes to 47. So 29 to 47. We'll disconnect this at the moment. 29 to 47. It's way down here. A long wire to do that. From 29 down to what is the microphone input. Now, also from 29 to 23. From 29 to 23. Oh, it's a transistor. To 23. 29 to 23. This will do it. Next one's 23 to 9. So 23 to 9. So we need a fairly short one. 23 to 9. Now remember what we're trying to do here, what I'm trying to do is take as many of these 5 electronic kits that I have and connect them together so they're all working together in some way. That's what I'm trying to, that's my my hyper project here. 23 to 9, 10 to 24, 10 to 24, so another fairly short one. 10 to 24. And you know what else you could get into using colored wire in a way that helps you understand the circuit a little better. Because the fact is, connecting these together, I'm not learning anything here except how to read a chart and stick wires under springs. 24. So the learning side of this is really kind of wide open. 24 to 20. 24 to 20. In the sense that it's kind of up to the person doing this to learn something from it. But I guess it could spark strong interest. 24 to 20, 37 to 17. 37 to 17. So now we're getting the volume control involved here. I wonder if this is going to work. So that means if you had a kid and they showed some interest and you gave them one of these things and they showed even more interest, you got to go to the next step. You got to do something more. Maybe you're heading into this kind of world with just loose, discrete parts. If you got a real hotshot kid who's really into it, this is only going to take you so far. Although again, if he started creating his own circuits, which is not an easy thing to do at all, then you can go further with this. 37 to 17, 37 to 17, 16 to 46. 16 to 46. Now, if you happen to be an electronics engineer or something like that, AM radio operator or something anyway, and you've got a child in your home who's showing interest, well, you probably have no shortage of things for them to work on. But would you want to include something like this in their repertoire? And I would say, yeah, for sure. It's pretty tight, but I think I can get away with this wire here. Yeah, I think so. I think this would be a pretty good thing. Where are we now? That was 16 to 46. We're almost done. 16 to 22. So 16 to 22. 16 to 22. Okay, towards the end you don't have much selection of wires, so I got to use this gigantic wire here. And the last one, 22 to 28. So 22 to 28. Hopefully I got one piece of wire left. And I can do that with. No, I don't. I've used up all the wire, so let's make another one. 22 to 28, something like that. How to do it. Actually, this very, very thin single conductor wire is really quite ideal. So this is probably the best wire. I think this is a telephone wire of a sort. It's really thin. It's very thin. It's a little thinner than usual. So frankly, I don't know where I got it. I got it from somewhere. And 28. Ooh, I feel the excitement building. What was that? 28 to 22. There it is. Now, last kit I built, I made a mistake and left off a whole wire, and that's partially because I'm talking away here while I'm doing it. So let's just go through this quickly, because it is pretty quick. We just go down the list here. From 1 to 11, from 11 to 21, from 11 to 14, from 2 to 8, from 8 to 12, from 7 to 19, 19 to 45, 19 to 45, 44 to 13, 44 to 13, 13 to 36, 13 to 36, 36 to 57. 36 to 57. 36 to 57. Where's 57? Oh yeah, oh that's right. Yeah, that's the power and not doing the battery and the switch and all that. We're doing the power differently. Okay, so that's fine. 59 to 64, 65 to 60, those are all the battery connections. 58 to 29, 58 to 29. 29 makes this the power part. I can put in the power terminal. 23 to 9. 23 to 9. Almost done here. 10 to 24. 10 to 24. 24 to 20. 24 to 20. 37 to 17. 37 to 17. 16 to 46. 16 to... What? Oh, look at that. This is a little too short. There we go. 16 to 46. A bit of a short wire there. 16 to 22. 16 to 22. And 22 to 28. 22 to 28. There we are. Okay, so it's all wired up. Put a little antenna on it here. There's our antenna. And the earphone becomes the microphone. Okay, let's get a radio down here. Suggestion is you're in the upper part of the band. There it is. Okay, well now we switch it on. It's 6 volts. There's 6 volts. For all I know, it's working. Here we go. That's interesting. How do you like that? Now my power supply may be very noisy. It's pretty broad. Okay, so I'm gonna have to switch this to a battery supply, or put a big capacitor in here maybe. Maybe we should do that. It's also not grounded, so the transmitter has nothing to kind of like push against, if you like. Now what I mean by that is, this is how I view an ungrounded radio. The signal's going like this. This part's on the antenna here. This part's just wasted. Okay, and that's what it's doing. Now when you ground it, you fix one side. And the other side goes more like this. That's how I see grounding helping. with boosting signals, boosting reception. Don't know if that's right or not, but that's how I envision it. So ungrounded. So these two terminals are kind of doing this. So this is as much an antenna as this. That's how I kind of envision it, until you ground it, which we may do later. But our real problem is that we have a very noisy power supply. Now, how should we deal with that? Should we put in a big honkin capacitor? Well, let's see what happens if we do. Now, here's my big honkin. Let's get one out of here. 47 microfarads. And I can attach it up here where my leads come out of the a lot of problems with voltage control on that amplifier. Or I can attach it down here. And I'm going to attach it down here. So we'll put the negative on the negative. Okay. And we'll just put it into this unused terminal here, the positive, and then we'll put a little bridge wire across there. Okay, let's see what happens here. Where'd the tone go? I haven't hooked it up yet. Here we are. Okay, you hear the tone. Doesn't make a hill of beans worth of difference. Means the oscillation is coming from inside here somewhere. Okay, let's put a ground on. Slight difference. I can seem to stabilize it. Just all across the band, it's everywhere. I don't know, what do you think? Is it a success? Ooh, blah, blah, blah. Is it a failure? Doo-doo. Doo-doo. Yeah. And there you are, another failed project on the Heathkit kit. Hey, ta-da! You know, so I guess maybe the message here is don't go out and expect to use a kit from the 1960s and not have a lot of problems. Maybe that's the message here. So, do a little bit of troubleshooting on this, but this is the second Heathkit thing I've tried here, and it's making some noise anyway. Okay, so let's read some voltages on these transistors. Voltages to ground. Well, that's going to present a problem, isn't it? Let's try this ground. Okay, so we got almost 6 volts coming into it. No voltage on the transistor. That's a little odd. No voltage on the transistors. There's the voltage. There's the voltage. Yeah. These two are connected in Darlington or something like that. Now, this is also why I think the educational component of this would be let your kid build this, let it not work, and then you sit with your kid and go through it and troubleshoot it. You being somebody who knows a little more about what's going on. Get out your voltmeter like I'm doing. Start poking around. So let's see what we got going here. So here's the audio signal from the headphone, microphone, amplified here, fed into here, and this is the oscillator, I'm sure, oscillating here. Here you get a combined effect, and out it goes to the antenna, combining the audio and the RF signal. So on this, now where's the battery? So positive, we should see full positive on 23. 24 should show us something too, as long as this base is conducting. The base is controlled from the control here. Oh, isn't that interesting? I had the control at one extreme, so maybe that's part of the problem. So it looks like the control is affecting the biasing of this transistor. Now that's what's going on there. Let's fool around with the bias control a little bit. Okay, if the tone we're hearing is coming from down in here, then I should be able to disconnect wires off of 22, and everything should go silent. Okay. So I disconnected everything from 22, no input on this. Still hearing it. So let's pull everything off 19. And it doesn't make any difference. Well, where's the oscillating coming from? If I can remove those wires, where's the oscillation coming from? that coil and capacitor there. Well, I disconnected the coil and it still keeps making noise. Okay, this is a real mystery now. I've disconnected the power from it and it's still making this noise. How the heck does that work? I've discovered something new. The single wire power supply. Okay, so my supply is simply putting out this noise here. Duh. Okay, the whole time you've been listening to my power supply. Well, I better run this from a battery. No doubt about it. Let's give it the 9 volts it deserves here. Jeez. You'd think they're trying to keep people from stealing batteries the way they package it. Wait, what's this? Reclosable? What? They're reclosable? You like that, eh? Okay. We'll shut off the noisemaker there. Goodbye to that. Our battery there. A couple of clip leads. Now this is supposed to run on 6 volts, but I'm sure 9 volts not going to hurt it. Small terminal is the positive. Are you positive? I'm positive. I'm positive. The positive is positive. And the negative. Now we're going to find out this thing doesn't work worth a hoot. And the negative was to 37. Well, maybe it's in one spot of the band now.
Whatever it is.
Lots of strange sounds on my AM radios in my shop here. Putting the ground back on there. I think I got the volume up high. Make sure I got the ground in the right spot, or the negative from the battery. Okay, children, start up your oscilloscope. And we're going to have to take a look at the scope and see if we've got any oscillations at all. You know, I just looking at this and seeing that guy there. You know what he's saying? He's yelling into it. It doesn't work. That's what he's yelling into it there. Hold the earphone up to the speaker of your radio and turn the tuning coil in and out until you hear a squealing sound. So they suggest using feedback to find the tuning point. So that sounds like a pretty good idea. There we go. I'm going to turn it up real loud and try this back. Okay, real loud. Okay, it's a Heathkit wonder. let's see what's happening on the scope here. See if we can find anything at all. So, I'm looking at the circuit analysis here, children. Let's see here. We'll look for a signal right on the antenna. There's nothing there, so we'll look for a signal at the output of T1. Which one is T1? T1 goes to the antenna. It's T1. Absolutely nothing there. We look at the input of T2. Input of T2. Oh, big DC voltage there. Anywhere in this oscillator situation, 0.01. Yeah. Okay, there's no action in this circuit anywhere. So that's twice now this older kit has let me down. could be these transistors are defective. My previous test suggested they weren't. See, I think I should see 9 volts there. See 9 there. Oh well. This just left me with a troubleshooting nightmare again. Uh-oh, I'm getting quiet. That means I'm using all my brain cells now and trying to sort this thing out. I should say, I'm using both of my brain cells now to try to sort this guy out. Let's see. To tune the transmitter, set the control switch all the way to the left and turn the transmitter on with the switch. Tune your radio to a place where there's no station near the higher end. Hold the earphone to the speaker. Tune till you hear a squeal. Move away from the radio and speak. Carefully adjust the tuning coil to where your voice sounds the loudest in the radio. Now adjust the control to where your voice is loudest and clearest. So you start with this control all the way to the left. Battery's connected. It's not breaking into oscillation. And I wonder if these transistors have a life. I wonder if germanium transistors, if that's what they are, just won't last. Well, anyway, I think I'm gonna have to leave it here now. So, there. What are we learning? We're learning this Heathkit not working out. Why exactly? Don't know. Could be bad connections all through here, the way it was done. But I don't think we're getting... I can turn that off. I don't think we're getting anywhere here with this kit. We gotta use it for something. But we're not going to use it for a wireless microphone. Yeah. Well, let's go on to something else, I guess. You know what I'll do? I'll check through the other kits and see if I can spot one that can do a wireless microphone. Or a little AM transmitter. It doesn't have to be a wireless microphone. Even an AM transmitter would be okay. Same thing, isn't it, really? Anyway, thanks for watching this unfortunate failure of another kit build here. See you later.